Dear students, in this video lecture we are going to see about the static indeterminacy and the calculation and formula for the static indeterminacy for different types of structure. Already we have seen about the type of general categorization of type of structure, that is rigid jointed plane frame, rigid jointed space frame, pin jointed plane frame, pin jointed space frame. Pin jointed means it is jointed as a pin. That is, there is no moment at that pin joint. The best example for pin joint is truss member. Plain frame means it is like a building, residential building comprising of beams and columns. So you have to know the difference between pin jointed plane frame and rigid jointed plane frame. Rigid jointed means a structural model like building. Pin jointed means like truss. Truss is the best example for pin jointed. So statical indeterminate structure deals with this formula, that is I equal to u minus e, unknown minus number of equation, that is the indeterminacy. There is a difference between static indeterminacy and kinematic indeterminacy. Two types of indeterminacies are there: static indeterminacy, kinematic indeterminacy. Static indeterminacy deals with the number of unknowns and number of equilibrium equations. Kinematic indeterminacy deals with the number of degrees of freedom. What is meant by degrees of freedom? As the name implies, it indicates what are the parameters that the structure or the end condition or the support condition can allow. That is the freedom of degrees of freedom. What are the parameters allowed is known as kinematic indeterminacy. What are the characteristics in a support in a joint is restricted is called as static indeterminacy. So static indeterminacy means number of count of restrictions. Kinematic indeterminacy means number of counts of freedom, allowable characteristics. So with this basic knowledge, we move on to the next slide. So the indeterminacy basically divided into static and kinematic. The static having external indeterminacy and internal indeterminacy. In this, external indeterminacy deals with the support reactions. Internal indeterminacy deals with the number of member deficient. External relates to the support reaction. Internal relates to the member deficiency. What are the terminologies? There are many terminologies in different books. Here we are using DSI, static internal indeterminacy, DSE, static external indeterminacy, DK, kinematic indeterminacy. So what is meant by external indeterminacy? Static indeterminacy is the summation of external indeterminacy plus internal indeterminacy. DS equal to DSE plus DSI. External indeterminacy is if the number of reactions are more than the equilibrium equation is known as externally indeterminate structure. So this term means about the support reactions R3, R1, R2. So if the number of reactions are more than the equilibrium equation, it is called externally indeterminate. In this figure, one vertical reaction is possible here. One horizontal reaction is possible and one moment is possible at the fixed support. And it is a roller, it will move horizontally, so there is no resistance in the horizontal direction and it is having a resistance in only vertical direction. So totally how many number of resistance or reactions created? 1, 2, 3 and 4. 3 reactions, 1 moment, so totally 4 number of unknowns. How many number of equilibrium equations available in this? Actually 1, 2, 3 and 4. Actually 3 number of equations. Sometimes the equations can be considered as 2. I will tell the situation where equation should be considered as 2. Here 4 number of unknowns, 3 number of equations. What are the equations? Summation of fx 0, summation of fy 0 and summation of moment equal to 0. So in this given figure, A horizontal reaction is possible, vertical reaction is possible, moment is possible. So we are taken into account, that is summation of Fx0, Fy0, moment 0. So there are three number of equilibrium equations. So 4 minus 3, so it is propped cantilever. This structure is called propped cantilever. It is one of basic indeterminate structure. So it is having generally the I value 1. I value equal to 1 for the propped cantilever. The structure is externally indeterminate to the first degree. I am going to tell in which situation equation is considered to be 2. You consider a simply supported beam with a vertical point load W. And what are the reactions it can get? Reaction at A RA, reaction at B are the two unknowns. Here number of equilibrium equations, moment equal to 0, summation of Fy equal to 0. I am not going to consider summation of Fx equal to 0 because there is no any horizontal load in the given section. There is no possibility of horizontal force in this beam. That's why I am eliminating the third equilibrium condition, summation of Fx0, and I am going to only consider two number of equations. And what are the unknowns? Two number of unknowns and two number of equations. So there is no indeterminacy. It is determinate structure, simply supported. And in that case, we can consider summation of Fx. How? This load, if you consider this load, we can able to resolve this load into horizontal as well as vertical. This is Px and here it is Py. So this beam is subjected to a horizontal force in direction x, y and the moment. So we should consider three number of equations, Fx, Fy and the moment. In any case of beam which is not containing any horizontal force, then you can consider equilibrium equation as 2 by neglecting summation of Fx. So in this condition, one vertical reaction is possible, one moment is possible. The beam is subjected to purely a perpendicular load. So I am going to eliminate the equilibrium equation 3, that is Fx0. I am not going to consider the equilibrium equation Fx equal to 0. So I have considered E equal to 2, unknown equal to 2 because one vertical reaction or y direction and one moment m is having. So unknowns 2, equilibrium equation 2. So it is a determinate structure 2 minus 2 equal to 0. Whenever the load is purely perpendicular, there is no need of considering summation of Fx. Summation of Fx. So in general case, we can consider for frame element, for truss element, you have to consider all the three equations. In some cases of beams, we can consider equilibrium equation equal to 2. So in this condition, the load is inclined, so the load is split into two components in x direction and y direction. So there is a possibility of horizontal force acting in the beam. So I am considering equation 3. Internal indeterminacy. If the number of internal forces or stresses can't evaluated based on the equilibrium equation is known as internally indeterminate structure. So static indeterminacy for different structures. So degree of static indeterminacy of rigid jointed plane frame. Already we have discussed about this name. Actually it is a frame. Simply we can call it as a frame. Technically we should mention as rigid jointed plane frame. So in a plane frame, the total number of unknowns will be 3m plus r. 3m plus r. How it comes? 3m. That is 3 unknowns. One is the axial force, one is the shear force, one is the bending moment. Here you can understood that is one vertical, one horizontal and one moment. So axial force, shear force and bending moment. So there are three number of unknowns in a member. That's why it is 3m. And r is the number of unknown reaction forces at the support condition. Here, if you consider any one section, this point will act upon this axial force, shear force, and bending moment. In addition to that, the support reaction should be taken into account. That's why 3m plus r. So r is the remaining unknowns of reaction forces, and also 3j plus r dash, that is independent equations, will be available as three equations of static equilibrium, that is summation of h0, v0, m0 in each joints. That is why it is 3j. That is why it is 3j. We are going to consider three parameters at a point, then we consider 3j. 3j plus r dash, independent equations will be available, that is 3. Equation of condition r dash is the number of members connected to an internal hinge minus 1. So r is the equation of condition, will also be available in some cases, that is internal hinge, internal roller. The total degree of static indeterminacy for a rigid jointed plane frame is 3m plus r minus 3j plus r dash. I am going to explain these terms. Actually, in previous slide, we have accounted 3m as each member. We have three components. One is axial force, another one is shear force, another one is bending moment for each member. That is why 3m. And R is the support reaction. R is the support reaction. Every member has three number of components. That is why 3m, and R is the support reaction. We have to add all these three to have 3m plus r. Minus 3j means, so these are all unknowns. These are all unknowns. One member having three unknowns plus the external reaction is r. So totally this component is u minus number of equations available. Each joint will have three equations. What are the equations? H0, V0, M0. That is why 3j. So the first term 3m plus r minus 3j is a normal form of the I equation. What is r dash? If you consider minus inside, we have to deduct something from the I value. If it is basic I, we have to deduct something from this indeterminacy value. What we are going to eliminate? So this r dash means as releases. Releases. We can release some of the characteristics at any point in between the B. By introducing hinge, we can make an additional equation, that is m equal to 0 at this point. So we are introducing hinge and making one release in between two members. So this hinge made between two members. So two members connected by the one hinge. So the number of members connected to an internal hinge minus 1 is the r dash. How many number of members? Two members connected between one hinge. So 2 minus 1 equal to 1. So one release can be given to the indeterminacy value to make the structure determinate. So general I term is 3m plus r minus 3j. That is 3m plus r means number of unknowns present in the structure. In that r is the number of reaction, RA, RB, like that. 3m means for each member there is an axial force, shear force and bending moment. That's why 3m. So 3m plus r minus 3j means these are available joints. Each joint will have three number of equilibrium equations, summation of H0, V0, M0. That is why minus 3j. In addition to that, some of the structure will have some releases. For example, a member is separated by a hinge means these members are considered to be separate members, that is two members, minus one hinge. So 2 minus 1 equal to, so I think you understand. So degree of static indeterminacy or rigid jointed plane frame. Degree of static indeterminacy 3m plus r minus 3j plus r dash, where r dash is the release. So this is u term, this is a term minus release. So you can understand I equal to u minus v. This is u minus v minus releases. If 3m plus r, the number of unknowns, is lesser than 3j plus r dash, means it is unstable. That is, it is not stable with the available numbers. 3m plus r equal to 3j plus r dash means stable, can be an unstable because the arrangement of members can differ. Statically determined, but it is statically determined because u equal to E. So it is statically determined. Next one, 3m plus r greater than 3j plus r dash means it can be stable. In most case it is stable, or some case it is unstable because there might be a situation of not having any member, diagonal member, or any some important member. If it is not present there, it will lead to unstable, but statically indeterminate because number of unknown is greater than number of equations. That is why statically indeterminate. Here number of unknowns equal to number of equations. Here number of unknowns will be lesser than the number of equations. In that case, you can understand that some member is not available. That's why it is unstable. Rigid jointed plane frame. So in this case, we can separate external indeterminacy DSE equal to U minus E. DSI equal to indeterminacy, that is number of closed loop minus releases. C means number of closed loop minus releases. Here R equal to number of unknown reaction, E equal to number of equilibrium equations, M equal to number of members, J number of joints, C equal to number of closed loops, R dash is the total number of internal releases, that is number of members connected with the internal hinge minus 1, that is M dash minus 1. So the internal indeterminacy is calculated by using the closed loops. What is meant by closed loop? If you take a frame means the combinations of beams and columns, and it is having some fixity at the ends. So this loop is called a closed loop. That is, if you cut at any section of this loop, this section will have three number of unknowns, that is one shear force, one axial force, and one moment. So it will create an internal indeterminacy. If a simple frame is like this with the fixity, this will not create any loop. Any closed loop will be created like this. So the internal indeterminacy is 3C minus R dash. So R dash is common. It is number of releases, either can be added to external indeterminacy or internal indeterminacy. Normally U minus E is our general concept. U is 3m plus R, that is unknown, minus available equation is 3j, and if there is any closed loop, it should be added here, that is 3c, and the releases should be deducted, that is R dash. So combination of these will create total number of indeterminacy. So the internal indeterminacy is 3c, generally 3c. In space frame it is 6 times c. So it is a plane frame, that is it is 3 times c. So rigid jointed space frame means it is 6c. External indeterminacy is number of reaction and equilibrium equation. Our reactions are 6m plus r because it is a space frame. In plane frame it is 3m plus r. The same way it is 6m plus r minus the available equilibrium equation is 6j. One joint will have 6 number of parameters, that is summation of fx0, fy0, fz0, and summation of moment at x0, moment at y0, and moment at z0. So all the three axis components should be considered. That is why it is 6. Summation of mx, summation of my, and summation of mz. All the 6 equal to 0 for a space frame. So 6m plus r minus 6j minus the releases, which is common in the as in the previous case. Internal indeterminacy is 6 times of closed loops, number of closed loops into 6. And coming to the releases in 2 dimensions, that is in plane frame, the formula is number of connected members with internal hinge minus 1. In space frame, 3 into number of members connected to the internal hinge minus 1. Because of the space frame, this 3 is multiplied with m minus 1. Degree of static indeterminacy of pin jointed plane frame. Up to the previous slide, we have studied about a portal frame, that is rigid jointed plane frame. Here, we are going to study about pin jointed plane frame. Pin means it is pin jointed. It is a pin jointed structure where the bending moment 0 and the load is transferred axially. The load is transferred axially as a compression or as a tension. The simplest form of a stable plane truss is a triangle having 3 members and 3 joints. Very simplest form, comprising of 3 members. Then for each additional joint, we require 2 additional members. For each additional joint, we require 2 additional members. Thus, considering all the joints except the first 3 joints that form the basic triangle, we need 2 joints, 2 into joint, because each additional joint will require 2 members. So 2j, and each joint will have its axial forces. So additional joint will require 2 members. So it is totally 2j. So the number of joints 1, 2, 3 and 4. The total number of joints is 4, but we have to consider the additional joint j minus the basic number of members joints, that is j minus 3. So considering all the joints except the first 3 joints to form the basic triangle, the number of members which is equal to, the number of members will be equal to 2 times of total number of joints available, that is 4 minus 3. So j minus 3. And then adding the first 3 members that form the basic triangle. The total number of members in the truss can be formulated as 2j minus 3 plus 3. 2j minus 3 plus 3. So it is the basic member, 3 members. So 2j, if you multiply inside, minus 6 plus 3. So it is 2j minus 3. In simplest form, it is a basic triangle. So if we need additional joint, you require 2j, and if you eliminate, it is minus. So it is 2j minus 3. So which is equal to number of members. So if you multiply 2 into 4 minus 3, 8 minus 3, which is 5 members. So that is number 1, 2, 3, 4, 5. So it is a calculation to find the number of members. How we are calculating, each and additional joint will require 2 members. So that is why 2j. And we have to deduct minus 3 for the extra members. So finally it is 2j minus 3. If a plane truss is formed with the 2j minus 3 members, that is m equal to m equal to 2j minus 3 if they are arranged in a suitable manner that the system cannot change its shape without the deformation of members, then a stable and internally determinate plane truss is formed. So if this equation satisfied, then the truss will be a stable and internally determinate one. The degree of internal legitimacy for a plane truss is m equal to 2j minus 3. So dsi equal to m minus 2j minus 3. Because why it is dsi? This term deals with the number of members. So the member will be inside the truss, that is why it is called DSI, internal static indeterminacy. So m minus 2j minus 3 and m minus 2j plus 3. And if you order this, m plus 3 minus 2j. So what is m? Number of members. What is 3? It is available equations. It is available equations. 3 number of equations minus 2j. So we can write this m minus 2j minus 3 in this form m plus e minus 2j. Pin jointed plane frame. The external indeterminacy relates to the reactions, support reactions. So u minus e. The internal indeterminacy relates with the members. So m plus e minus 2j. If you add these two, that is m plus e minus 2j internal plus r minus e, that is external, you can get final equation m plus r minus 2j. R is the number of unknown reaction, that is Ra and Rb are the internal reactions, m is the number of members and j is the number of joints. So we can able to divide the truss member into stable, deficient and unstable. So the degree of external indeterminacy is u minus e, that is u minus e, which is r minus 3. Degree of internal indeterminacy m minus 2j minus 3. Degree of static indeterminacy, degree of which is equal to degree of external plus internal indeterminacy. Finally, we got m 2j minus 3 for the comparison. If the number of members is less than the 2j minus 3, it is internally unstable. If the number of members equal to 2j minus 3, it is stable but can be unstable because if the arrangement is like this, the bottom member is not present here, even though it is determinate, this structure can be a unstable structure. So there is a possibility of stable and unstable in this condition m equal to 2j minus 3. M greater than 2j minus 3, the structure definitely will be an indeterminate structure because the member is more than the 2j minus 3 value. And also the structure will be overstiff. So this is in previous slides we have already discussed. Similarly, pin jointed space frame. Here we are using 3j. Instead of 2j, we are using 3j. And the number of equilibrium equations can be formed with 6. And if ds, that is static indeterminacy, less than 0, it is unstable, statically determinate, equal to 0. That is, here ds means m 2j minus 3. M minus 2j minus 3 is an equation. So ds less than 0, ds equal to 0, ds greater than 0, we can able to differentiate unstable, stable and indeterminate structure for a pin jointed plane frame or pin jointed space frame. The pin jointed structure means it indicates truss member. So with this, we conclude statically indeterminate structure. Next video we are going to see about kinematic indeterminate structure.